already had a actually, what we initially thought, I just thought maybe he just had some corrosion on the screen connectors was all. Because I took up this plate and around our M2 CPU. This is an M2 MacBook Air, A2681. What we initially thought was that maybe there was just some corrosion around the screen connector. There was. The 5-volt cam line here was burned. We're going to run a wire from these 2 pins on either side and the end of this capacitor, which doesn't actually have a pad there, through this little plate to somewhere over here where those go. We also replaced this guy. This one, all of the pads there were fine. We just refixed those. Screen connector itself is fine. This person's screen is probably also bad. This looks all fine. And then over here, we actually had quite a big mess. I took screenshots of the corrosion areas beforehand. I have cleaned this off now with a brush and alcohol so I can actually see things a little bit more clearly. It's fairly corroded in this area. There's a few parts that, maybe we don't have a short in those lines, but they look ugly. We're going to replace them. What we did find, though, was a short circuit on a 3.8 volt line, 3V8A on WLAN, Bluetooth, something like that. It's this guy right here. We have a dead short on there, so we soldered a 36 gauge wire on there. We're going to send some power through it, then we're going to turn on our thermal cam and see what we find. See. And really, well, unless you had a machine where you maybe have some damage around CPU MOSFETs or something like that. If you see liquid damage, you could probably get the thing working. I would. What I generally do is replace stuff that just looks obviously bad, or just for example something like this. We checked around for short circuits. We found one on this line. We're going to resolve this short circuit, and then replace some parts that are ugly. Then we're going to ultrasonic the board, and then I'm going to run power through the USB-C connectors and see what it does. Okay, let's get our thermal cam software up. Should have something right over here get hot. What I'm seeing is maybe this little guy right here. See if we have anything else on the board, maybe. Oh, well, there's our fucker. And we have found the fucker. He was over here, so not directly on the line, but some other 3.8 volt line. And you know what, actually, if we followed my, rule of just replace things that are ugly, we would have just fixed that short, actually. We saw that cap earlier. That's something. I believe it's actually like this guy or something like that. Here, I'm going to put some alcohol near the area that was shorting. We're going to put the thermal camera away. So we already found our fella. I'm thinking I probably shouldn't swear in most of the board repair videos. I want you to be able to see this too. So here, if we just look at this, we'll switch over to. Ooh, that's clean. That's clean. Look at that transition. Ooh. All right, so there's something over here getting hot. I'm putting some alcohol on it. And yeah, we can see that. So this is something that we already saw and it looked ugly earlier. So this is causing this even interacting with? So, I guess somehow this is bringing down our boy over here. Let's look at this. So this is just this capacitor stabilizing voltage on 3V8 AON, so that's why we're getting a short on this other 3V8 line. We are going to remove it, and we're going to replace it with one we have from a donor board. I'm going to desolder the wire over here. Some flux on there. I think we're just going to replace all 4 of those caps because they all look ugly. And we're just looking at this. Hot air 430, airflow 120. This is pretty much what I'm using 90% of the time working on a MacBook. These M2 Airs you could probably get away with a little bit less heat because the board's small. It's more like an iPad board almost. Or just keep the hot air moving. You don't want to just stick the hot air in one spot and burn the PCB. And we got like no pad. Go ahead and just remove some other sad components while I'm at it. I think this guy's going to be bad right here, this resistor. We'll replace that. Yeah, why not? We'll replace this guy too. He doesn't look too happy. And I'm going to get this guy off. This guy probably has no pad underneath. There's a secondary fella under there. There's our shield plate, which is annoying. Probably move back that shield plate a little. I think we looked at that earlier. It was like a camera driver or something or other. Let's get some more flux. She's gonna go ahead and put this in a holder. We're scanning for sad looking things. That was the guy I wanted to. I don't like him, so I'm gonna remove him. Yes, we're going to remember every component we removed, and we'll replace all of them. Yeah, a lot of sad stuff right here too. I think we want to get rid of. Now these BGA chips I'm not going to remove so flippantly because they're annoying to replace. These little surface mount components really don't take much time to replace, and you know, if they're not bad now, they'll, you know, maybe fail later, and I don't want to do warranty repairs. That's no fun, you know. If we get them, we'll do them, but I'd prefer not to do that, so I'm going to replace stuff that looks like, maybe it's not the best to leave on there. The guy on the left looks more okay. Also just kind of get to reflow the solder in all of these areas that were a little toasty from the liquid damage. Flux works well to kind of clean everything. Shot a capacitor. Oh, well, you know, it's not supposed to be there. Go ahead and lower my airflow on this. Go down to like 80. And double check our schematic. Where am I? Right there, PP bus Aeon. So this guy should be facing this way. Looking at the little dot. This capacitor here is directional. That's why it has a little dot. Get out our micro pencil from Haka USA. Touch up these guys. We'll touch up this guy. We're going to touch the MacBook in places it's never been touched before. Touch up these pads on our shorted 3V8 Aeon caps that we removed earlier. I'm just looking at the spots where we removed some stuff. I want to see if we need to actually touch up the solder underneath. And that guy for sure. We're going to peel back that shield plate. So I like to kind of add flux after I've gotten off all the bad parts, because it's like marking, putting like little, you know, waypoints basically on where to go back to later. Gosh, do you have one of those little like snips, those little Hako snips, the red and black ones? Yeah. Thanks. The shield plates are much denser. This MacBook Air is going to lose 0.01% of its thermal mass, but it is so that it may live again. I just want to be able to get a good look at those guys under there. Looking around a little bit. I think it's good to just, like, if you're moving a bunch of stuff from one donor to another, it's kind of just easier if you have your whole area prepped, because then you can just kind of be hot airing on all of your components. You don't need to stop. Oh, I need to get my iron. I need to, oh, this pad's fucked. I need to tin up this pad, etc., etc. That looks fine. And this is how you kill your micro pencil tips, by using them to scrape shit like this. They simply work too well to do this. So there's a sacrifice we're gonna make. Alright, let's start grabbing stuff off of our donor, and I think after that we'll ultrasonic this board, and then we'll run power through it and see what it does. We'll get the donor. Sacrificing this MacBook board so that another may live. So these guys, some guys over there, we got a guy there, those fellas. Where do we have more fellas? We had some more fellas here. Here. I'll probably circle back in a second once we're moving stuff over. First things first. We're gonna do this. I'm not gonna be as gentle on my donor, my cadaver. This MacBook's, this board's purpose is solely for fixing other MacBooks. Turn apart airflow. Grabbing these parts and I'm setting them roughly where they belong on the other board. I like to do into sections. We'll do these two caps, then we'll do those two resistors, all of our little flexing areas. Now, when your hot air is like really, really high like this, you always want to kind of like sneak up on the components you're doing, especially if it's little surface mount components like this. Should kind of flow into place from the surface tension. Now I'll give this guy a little help. More flux. Burn my hand. Doesn't really matter if the capacitor is slightly diagonal, but it'll bother me. So I'm gonna make them straight. But you know what I should do? Just look at these resistors that I grabbed here. I might just have some in a bin. 470K. Yeah, they're both 470. Okay. So I'm gonna pull these off the donor. I don't think I don't have these in a bin. I'm gonna grab these guys one at a time, and I'm gonna follow with microscope. Put some flux down there so they stay. wouldn't be surprised if we end up needing this CD32 from this board. These chips are just so sensitive. And on the M1, I would imagine it's the same for the M2, but you need to pull, we'll need to pull a CD3217 from another M2 board, I would imagine, or possibly an M1 board. I'm not sure. But if we think our CD32 is bad, we'll find out. And if so, we would take the one off our other board there, we'd reball it, and then get it on this one. No, just put some more flux. This guy. And he swooped into place. And then we had another guy right there we're gonna grab. And a lot of these caps, this one probably doesn't need to be replaced. Most caps don't. Just for example, we had one near the Wi-Fi driver, which I just removed. We're not going to replace that. It's near the Wi-Fi driver itself is underfilled, and just applying heat in that area is, you're risking eventually damaging that chip and causing a big problem. It's really just not worth it. And there's already a lot of caps on 3V8 AON to stabilize that bolt. We don't need we don't need all of them on there. And we'll work fine with no issue. Alright, we're gonna get our four fellas here for these guys. This is a fun trick. Go like this. And then we accidentally grab those three. We don't want those ones. It's magnifique. Which side are these guys going? Yeah, probably wasn't the greatest idea to do these kind of in a big blob together. So, let's see if I can find where I shot that capacitor. There it is. Okay, we're going to do these one at a time. Some more solder. These pads. Should be fine. This is just we just got too much solder on this cap. Now I'm just gonna grab some wick. Fuck. And we really don't want, that's ground above, so we really don't want these bridging. If they were like just for example, if these two were bridging up, right, these guys they're on the same line, it wouldn't really matter. These guys, they are, we don't want them touching that. That causes a big fuck off problem. I'm gonna zoom in a little more here. I want to make sure we're all right. That looks okay. This does feel a lot more like fixing an iPad board. We're gonna live that guy being a little bit diagonal. Fucker. This would have been a better way to do this, would have been left to right, and I do them one at a time. But I was trying to be lickety split. Now I've just cost myself more time. Now that pad's a little bit wonky, so it's kind of falling off a bit. Oh, fucker. Just lost one forever. Okay. 10 UF. It's the same thing. Let's see. They're the same thing. Alright, we're just going to pull one from directly above. They're the same values. And this one I can just hold fucking in place. Should have room. We're going to be okay with that. It's connected to the lines that we need, and you know we have that there. Okay. What else? What else? Place a fella. I'm actually going to go ahead. These guys are all 10 UF. Same value over here. I'm just going to put these parts back on this board. Doesn't really matter where. So I can use them later if I want. There we go. We'll do that. We'll do that on our donor. Gosh, I spent so much time on that I kind of lost my train. I remember we had these guys over here. I think that was our primary our corrosion area. I'm going to go ahead and just touch up the solder on this because it looks gross. Looks like no stuff. Alright, so I guess we just have this little guy. And we had those up there too. And we had two fellas here. Go left to right. I mean, if you're left-handed, you probably go right to left. this is that cap we removed earlier. We're not going to really bother replacing that guy. I think we're going to go ahead and ultrasonic the board. I guess I'm going to double check. I don't have any shorts over here. Just want to make sure. Double check our shorts gone. Just in continuity mode. Black rope on ground. That might be because we're... Okay, several million ohms. Can you tell me what that says?
It's like 1 ohm. 1.6 megaohms.
Okay, we're chilling. Alright, so I reckon, I wonder if this line is just supposed to be, yeah, P ground. Okay, so this line's, oh, actually, so this didn't matter at all that these were touching. This is P ground. I was like, that's actually, I was thinking like, oh, that's kind of weird circuit design. Why would they put 2 ground lines like that? Okay, alright. Okay. Well, this maybe works now. Maybe we have a bad CD32 or this little camera driver guy over here didn't look too happy. These guys are speaker amp stuff. They didn't look too happy either, but we reflowed the solder on them. We're going to ultrasonic the board now and see what happens.